Hello students, there is a numerical on top. Please solve this problem.
That's
What is the answer you got?
option D, sir.
You have solved this problem before?
No, sir.
Let me wait for the question to solve. Anybody close to solving? Hello, now please keep answering. Say yes sir, no sir, like that. My system is working on hotspot, so I have to be sure that the connection is okay. Right?
Yes, sir.
Okay. Now, anybody else has solved? Abhinav says the answer is B. Okay. I think most of you are struggling. So the problem is not that difficult. What you have to see is there is a single rope through the pulleys, so the tension everywhere is same. So here the tension is T, here the tension is T, here the tension is T. And therefore this is T, 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 and the tension here is 2T. Okay. Now if you see this system, this person has a system with this one. So you can see T and 2T acting in the upward direction, and the other force that is acting is in this direction due to his weight. So this will be mg sin theta. Okay, and the sum of all the forces on this side is going to be 2t plus 3t. Okay, 3t. And now the thing is, they have told that the force F is being pulled by a force of 250 newtons, and the mass is 100 kg, and the trolley is pulled in an inclined. The trolley is being pulled in an inclined plane by man. So its pull means he is trying to go up. So in this case, they have given this value. They have given this value. You know this, and this value is also known. So therefore, they are asking you the acceleration. So here the situation is quite simple. The acceleration in the upward direction will simply be equal to 3t minus mg sin theta upon m. Okay. So plug in the values. 3 into 250, because the element T is 250, m is 100 kg, g is 10, and they are given here sin 15 is 0.26 and divided by 100. Okay, so here you just have to manipulate it. So here you get here 750 minus 260 upon 100. Since the choice is given, don't try to solve this. Okay, so you can approximately solve this. I would say 260, take it as 250. So this becomes 500. 500 by 100. So this is equal to 5. So answer should be close to 5. You have one option, D. So D becomes the solution to the problem. Okay? Hello?
Yes, sir.
Yes, done. Anybody is having any question? You can please ask her, feel free. You have all come to learn, I have come to teach. And that's our relation. Okay, so therefore, please feel free. Right. We'll go on to the next sum.
Yes.
Huh.
Yes.
So we just completed the 13. We'll move on to the 15th sum. I hope the numerical is visible to all of you.
Yes.
Yes.
Visible and legible, etc., etc. Okay, please attack this problem. Aram se. Sorry, I think I should have given you the 14th problem. We'll solve it. Okay, you are doing 15, then we'll do the 14th. And again you notice that the string is the same string, only one string. And that is moving through. Therefore the tension everywhere is same. So you have a point C and you can take another point D, that is there's that pulley is C, this pulley you take it as D, and try to see the write the equations of force on C. So for pulley C, okay, so what you see here is for pulley C there is a thread up and there is thread down here. So there are two threads. In fact, there are two strings down. So for this pulley, you have one string up and two strings down, but the tension has to be same. So if you take these two tensions to be same, T, these two tensions are T, and this tension is 2T. And they are told the massless pulley. So this pulley is massless. So if this is massless, then you will get a condition here that is this is 2T and this is T and this is massless. So this condition is only satisfied if T is equal to 0. Okay, so that means there is absolutely no tension in the string. So it's like this: A and B, you hold it in your hand, and the moment you release, there is no tension to pull it. So therefore, A and B will have a free fall, and therefore both will have acceleration G and G. So the option is D for this.
Yes.
Correct?
Correct.
Correct. Arun is here. Happy to see him here, and he says the answer is correct.
Yeah.
Okay, shall I move on, students?
Yes.
Okay. Feel free, if you have questions, you please ask. Right. I think I missed out the 14th question. Question, solve this. If it is not visible properly, you can tell me, I will make it big and small. God has given all this provision, so let's make use of that. So there are 4 arrangements, each having mass m. Which arrangement will take minimum time? So all are going to go up, and well, it will go up if there is net force, because it's being pulled. So what will take them faster up is, what will take them up faster?
More force.
Acceleration. So which has more acceleration, that will go. So which has more force will have more acceleration. So here you see what is the net force acting on the two masses. Here the net force acting on the two masses will be 2F. Here the net force acting on the two masses will be 2F. And in this case, F is divided into F by 2, F by 2. And therefore for this, the net force is going to be F. And here again the net force is going to be F. And here again it is going to be F by 2 in this case. Okay, so whichever force is more, so this force is more, so the option is A. The option is A. Okay. Hello. If anybody is having questions, even including the theory, you can please ask. I will be more than happy to help you. Question, Mr. Arun? Then you tell me to pause. No, I will pause. Why are you keeping quiet? You should have told, sir, wait, sir, I am going to solve. Because I am not getting any response, I am solving. If you feel you can solve, you can tell me, sir, wait, sir, I will solve. See, this is a training session. So I am giving you training, I am coaching and training. But of course, if you have issues with the theory, I am ready to help you with theory.
So net force should be greater than this.
You please speak loudly, otherwise I will not respond. Huh? See, everybody should hear your question. Huh?
Net force should be greater than this.
Net force should be?
Greater, so that the mass will accelerate.
Huh, yeah.
So the last case,
Huh.
it should be F by 2 minus 2 mg.
No, why are you bothered? See, 2 mg is there.
Is there
2 mg is common to all, no. 2 mg is common to all, no. For all 2 mg is common, therefore I have not written.
Okay.
See here,
Okay, sir.
the net force here will be this minus 2 mg. This minus 2 mg, this minus 2 mg, isn't it? That is common. So why bother about it? So only one thing is there. So here you see we have to see, that's what I'm telling you. Mechanics, it's not just the formula. See, you are driven by formulas. Formulas should be used to get the answer, but you should get the feel of the problem. Okay, that is important. Right. Shall we move on, students?
Yes.
Aryan, what is wrong with you?
Yes, sir.
See, others, at least, they are not responding to me. Even though I talk, at least you are a good boy. You keep telling yes, no, yes, no. Okay, nothing will happen. Your energy will not come down. Clear? Karnataka. See, it is, you have to demand. You have to demand. And you be quick.
Yes.
Don't have to be frightened of me. As if. Aram se study and do. This problem you should be able to work it out. Sorry. Well, there is something standard here. I hope all of you notice it. What is it? How do you go about solving?
We'll make a few.
जोर माताಡ್ತಿಲ್ಲ free body acceleration
due to the gravitation.
There is something very fundamental in such problems. You want to draw the free body diagram of
Sir, you are stuck, sir.
Okay, am I audible now?
Yes, sir, you are audible now, sir.
Thank
Yes,
you.
yes.
Thank you. See, Abhinav is such a good boy. Please, remind me. Okay, so you want to draw the free body diagram of the block, isn't it? So the free body diagram of the block, if you take that block there, okay, so you have this, and then you have the block here, and they are told that this angle is 30 degrees. So now here you see the wedge is accelerating. So if you want to draw the free body diagram of the block, right, and use Newton's law, then it is situated on a frame which is accelerating.
Yes.
So you have to stop it.
Yes. Stop.
Notionally you have to stop it, isn't it? So you will add a pseudo acceleration to it. You will add a pseudo acceleration to it towards the left.
That's it.
Towards the left.
Left,
Isn't
yes,
it?
sir.
You will add a pseudo acceleration towards the left, and obviously you have got mg acting down. Okay, so these are the two
Yes, sir.
forces that are acting, and of course there is a third force, that is the normal to the surface. Okay, so these are the vectors that you have to consider, and you have to make this one. Okay, now go systematic. One thing is, you notice that well, there is no freedom to this along this axis. That is, there is no motion along this blue line or this axis.
Yes, sir.
Okay, that means the n has to be balanced. N has to be balanced. Okay, that n gets balanced. That means now you will take the component of this and component of this in this direction, and those two components must be equal to n. So n is nullified. So you break this into two components. So one component will come here, and the other component of this will come along this direction. The other component of this will come along this direction. This is mg sin theta. Okay. Now this is 30, so this is also 30 degrees, and the other component of this will also come along this direction, isn't it? So this is what
Yes, sir.
this component will be, m a naught cos 30, right?
Yes, sir.
And they are told the block is moving towards the right with acceleration. The length of the plane is AC. So the length of the plane is AC 1 meter. Friction is upset. Time taken to go from C to A. That means it is moving in the upper direction.
Obviously.
So you have to calculate the acceleration in the upper direction. Acceleration in the upper direction will be what? It will be A naught cos 30 root 3 by 2 minus G sin 30. G sin 30 is half. This will be the net acceleration. Okay, and A0 they have also told it is also G. Okay, so here the net acceleration is going to be simply G into bracket root 3 by 2 minus half. Root 3 is 1.73. So 1.73 minus 1 will be 0.73. So this is going to be 0.73 divided by 2. This is the net acceleration in the upward direction. Okay, and then rest is, they have asked you to, they have asked the time taken. So the distance from C to A is given as 1 meter. 1 meter is equal to, and it starts from rest. So this is half into A. A is 0.73 by 2 into T square. Okay, into T square. Now don't do any manipulation here, just take it here. So therefore you will get T approximately, I will write it as 2 divided by root of 0.73. Okay, root of 0.73. So this approximately I will write it as 2. So if we take
So it should be 0.73 into 10 because G are not.
Yeah, I have not taken G, sorry. 0.73 into 10, I'm sorry, into G. So this should be, point should come here, point should not come here. Point should come here, point should not come here. And therefore, this will also be 7.3. So therefore, root of 7.3 will be more than 2.5. Or more than 2.6. Okay, more than 2.6. So I'll take it approximately 2.6. So this should give you what? 2 divided by 2.6. So even if you take it as 20 by 26, so you will get it as 4 5s are 4 approximately 4 7s are. So 5 by 7. 0.7. So I think the option should be B. So close to 0.7, option should be B.
Yes.
Okay, if you do it correctly, you will get the option as B.
Yes.
If somebody has done it very quickly, you will get the option B. So this is a very simple problem. See, in mains, they are going to ask you such types of questions, and maybe even in NEET and mains, most of the questions will be like this. And in the NEET, at least about 15 to 20 questions will be of this level. CET maybe 4 or 5 questions may be of this level. Okay? So my dear friends, see, now that yesterday I got the information that maybe your mains will be postponed from January to March. So what I will do is, by this as per the plan, let me continue and complete your entire syllabus. Entire syllabus I will revise like this, and we will be completing by January. Then still we have 3 months. So I will take up again next set of exercises similar, but that will be at a higher level. I will choose questions which have more than one option correct. So they are slightly more difficult and in consonance with the mains. So you will be better trained. So we will use that time and train you better. Okay. Shall I proceed, students?
Yes.
Yes, sir.
Are you comfortable with everything that I am doing? I am making it much better than yesterday. I got the problem here. Means always the numerical is visible, and my board work is now a better improvement. Thanks to Arun who is sitting here. He gave me a suggestion yesterday that, sir, you go to the board and solve. Right. So suggestions, good suggestions are always welcome. Under 16, 17th. Okay. Who annaka ಏನು ಓದಿದ್ರಿ?
Yes,
ತಲೆ
yes, sir.
ಅಲ್ಲಾಡ್ಸೋದು, ಅದು ಅಲ್ಲಾಡ್ಸೋದು, ಇದು ಅಲ್ಲಾಡ್ಸೋದು. Fully A and B are massless, only C is having mass here. Friction in the pulleys is negligible. Again, aram se analyze, no hurry.
Sir,
Ask.
sir, in this question,
Hmm.
they are given that C, pulley C as mass.
Hmm.
Can we model it as a pulley without mass and attached to it is that mass of
Right.
block? And
Why do you want to make it like that?
so massless pulleys are easier to manipulate, sir. So we will make it into massless pulley with with attached mass.
Okay, do it, see. You can do it, not an issue. Okay, at least you notice one thing now. As far as pulley A is concerned, it is the same situation. The tension up for that is 2T and the tension down is T, and pulley A is massless. So again the same situation as we had encountered before. So the tension in the string is 0.
Yes, sir.
Hello, the tension in the string is 0.
Yes,
Okay.
sir. Correct.
So therefore now, that is, initially you are holding pulley C in your hand. The moment you release it, well, then there is no tension in the strings. Okay. However, this problem is slightly different than the previous problem. So you have to now see the end A, right? The end of pulley A, and the other point for the pulley C is connected to a pulley which is fixed. Okay, pulley which is fixed. So B is not free. B is a fixed pulley, and therefore C tries to come down. Then A has to go up. So that means now C will be pulled up. Because C is the one end of C is connected to A, and A is going to go up, okay, and the other end of C is trying to come down. So therefore, it is a constrained motion.
Yes, constrained motion.
It's a constrained motion, but the tension is 0.
Tension is 0.
It's a constrained motion with tension is 0. Do you appreciate that, students?
Tension is 0.
Hello?
Yes, sir. Yes.
Hello?
Yes, sir.
So what will you do? See, just tell me what will you do under this circumstance. Feel free, this is not examination. I am not, it's not a test or something. So under this circumstance, what will you do? See, I am working on your mind, your mindset. Okay? What will you do under this circumstance? See, how am I training you? You are stuck at one level, then you should go to the lower level. You remember your classes. How did you learn this theory? You learned from simple things, drawing L, L naught, etc. And then you came down to this level, correct? So if you are stuck at a higher level, you should go to the lower level. Okay, do you remember that lower level?
Yes.
Yes, sir.
Then go with that lower level. So what is that lower level you have learned? So from here to here, you took it as L1. You remember? Hello?
Yes, it is.
This one you took it as L2, this one you took it as L3, this one you took it as L4. I hope you remember this.
Yes, sir.
Yes.
Then you went about writing the equations. L1 plus L2 plus L3 plus L4 is equal to a constant L. Right? Now, you have to go and say it is accelerating, whatever it is. So you have to find out accelerating. So you will differentiate this. So if you differentiate it, well, you are going to get here L1 dot or double differentiation will give you L1 double dash, okay, plus L2 double dash plus L3 double dash plus L4 double dash, and this is going to be 0. That is the second step you have done. Hello, everyone? Now, what else have you learned in the theory? You have learned that, see, this one can move, this one can move. Therefore, you will take this distance as x1 and you will take this distance as x2. Correct?
L1 plus L4.
Okay. Hello?
Yes, sir.
Yes, sir.
So, then you have to keep writing the equations for this here. So, L1 will be what? L1 double dash will take it as x1 and L2. What is L2?
X2.
What is L2? x2 minus
X2, not X2 minus.
It will be X1 minus.
X1 only.
It should be x1 only.
Yes.
Correct?
Yes.
It should be x1 only.
We can take one point on that and one means if it's going down by A acceleration, it should go down by A acceleration down.
ನೀನು ಮಾತಾಡಿದ್ರೆ ಯಾರಿಗೆ ಕೇಳಿಸ್ಬೇಕು? ಸ್ವಲ್ಪ ಜೋರ್ ಮಾತಾಡೋ ನೋಡೋಣ ಏನಾಗ್ತೈತಿ? ಇಲ್ಲ ಜೋರಲ್ಲ ಅದರ ಕೇಳಿಸ್ ನನ್ನ ಧ್ವನಿ ಅಷ್ಟು ಅಲೌಡ್ನೆಸ್ ಕೊಡ್ಬೇಕು. Why should come to my level?
Okay.
Yeah, that's the way to speak. Yes, please.
If we consider on pulling X on those two strings, if it is going up now,
It is going up. So therefore now you have taken, see, this is dot. So this also you write it as
X1.
That only you wanted to tell.
That one.
Okay. Then what about L3? L3 will be x2.
Yes, it will be
Correct? And what will be L4?
X2 minus X1.
Yes, good. X2 minus x1. Okay, so these are corresponding to this. Suppose, hello, understood? So here you see 1x1 and this x1 cancels. So you get here straight away 2x2 minus, 2x2 plus x1 is equal to 0. So, or in other words, you have here x2 is positive or x1 is negative, whatever. So it only says that, what does this equation imply? That is, the system is going to accelerate.
Yes, sir.
Only thing is, and the tension is 0. Tension is 0. That means C now, x2 stands for C, right? So twice the acceleration of C is acceleration of A. Twice the acceleration of C, and C cannot accelerate more than G.
Yes.
So if the acceleration of C is G, if the acceleration of C is G, then the acceleration of this has to be what?
2G upwards.
2G upwards. Agreed?
Yes, sir.
Okay, think carefully.
Yes, sir. Yes, sir.
Fine, students?
Fine.
Okay, so this should be the option. So acceleration of pulley A is 2G upwards. So D is the answer. So D is the answer. Okay, so this is it. Same, the same situation I have chosen. I have chosen a problem with, T tension is 0. But here you see, though the tension is 0, there is a constrained motion. Okay, and I'm sure. See, this is what I'm trying to tell you. You get stuck at this level, then you go one level low. You still get stuck, go low. You should not sit and start grouping, oh, what to do? What to do? Okay, I didn't get it at this step. Let me go down. Okay. Hello, can you hear me?
Your voice had gotten stuck.
No, I know. That's what I said. Can you hear me? You say yes or no. I got the message here.
Yes, sir.
Fine. So you get stuck at one level, you should go to the next, the lower level. See, the thing is, as you get a lot of, if your attitude improves, Okay, then if your mind is free, then you will be able to absorb the knowledge and skills at a higher level. So you can solve problems at a higher level, I mean without much thinking. But if you are not able to solve, that only means you just have to be humble enough, go down and think. But what is happening to all of you is, most of you is, you have put a thing in your head that you are IIT students, you are very brilliant students. So there should be something very brilliant, I should use my brilliance and solve the problem. No, leave that. Brilliance, you keep it somewhere. Here, you just have to use science, and the technique is just apply science, try to get the answer. If you don't get, go low, still apply science, go low, still apply science. And yes, you should partition the problem logically and attack it one part by part, then join and get the answer. Okay, shall we proceed, students?
Yes, sir.
Yes, sir.
Yeah, so we will move on to the 18th.
And that's
Right? I think. Yeah. So this is acceleration versus time graph.
yes.
Yes.
What is your answer?
C option.
Arun has got B, you got C. Somebody else? See again, everybody those of you are getting stuck. Don't go one level low. What is that level low? Huh? So now, what is that level low you have to go? Right? So the level low that you have to go is F is equal to KT. You plot F is equal to KT, you will get an idea because these are all graph. So if you plot F is equal to KT, okay, F versus T, then F versus T graph will be like this. Isn't it?
Yes, sir.
And you saw basic thing. The acceleration will follow force. That is Newton's law. Acceleration is directly and instantaneous. Instantaneous and follow the path. I mean, it will be in accordance with F. So therefore, the graph selects this. See, this is nothing but this. If you divide it by m, then this F by m graph, okay, will be one of these graphs. So which one is going to suit? This one. Now here you see. The question here is till this point force F is given. So F is equal to some value. So I will take it as small f. F is equal to some value F1. Okay. The body is on a rough surface. So there will be yes, there will be static friction. Unless it reaches maximum value, it will not. So therefore, up to this point, okay, the point is F max. That is static friction max. Okay, and then it will start going. So see the option. See, this is again a very fundamental question. Why did you choose B, Mr. Loud? Why did you get B? Why? What made it? See, I want to know where you are going wrong.
F is KT.
Pardon?
Correct ನೋಡಿಲ್ಲ ಸರ್ F is equal to KT.
ಯಾಕೆ ನೋಡಿಲ್ಲ ಕರೆಕ್ಟ್ ಆಗಿ ಮುದುಕಾಗಿ
ಇಲ್ಲ ಸರ್.
See if I am 58 plus, so I can say, oh sorry, I did oversight, and I don't have to write exam. You are such an youngster. How can you overlook? No, what is the problem in you because of which you oversighted? Why did you oversight it? Why did you not see it properly? Come on, I want to correct you. Why did you not see? Mr. Arun is telling that he did not properly see F is equal to KT. He is sitting in front of me. So I am asking him, why did you not see that properly? What was going on in your mind? The problem is, when you get a problem like this, you think it is very simple. Both two things are happening in each one of you. Either you think the problem is simple, or you think the problem is very difficult. So in both the things, your attention goes, your concentration goes. So don't be humble. Okay, this problem is a problem. Every problem is important. You just have to apply science and get it. Okay, that is what you should be. See, the problem with Mr. Arun is, he is a good boy. He knows science. But the problem is, his attitude has not changed. His attitude has been the same thing. Okay, that is the reason why. And there are ways of actually getting to know the problem. Right? Unfortunately, most of you are driven by formulas. So here, you start hunting what is the formula for this. There is no formula for this. So that is it. That is why, I don't want to teach with formulas. Get hold of the problem. Okay. So we just completed 18 and 19. Okay, Mr. Arun, sufficiently large? Solve this. So follow the steps. What happens step by step you see in this problem. Understand the nature, nature of the motion here. Understand the nature of the motion. Did somebody first examine whether the bodies will slide? Hello? Did you make sure both the bodies can slide? Will both the bodies slide? So first make sure both the bodies will slide. So if you take any one body, right? Well, the force acting here will be mg sin theta. And the normal is there, and well, if you calculate the friction, mu mg, so this is going to be mu mg will be the frictional force. Okay, now just have a look at it. It is 60, so the mass given is 1 kg, 2 kg, so therefore whatever be the mass, so if you take it as 1 kg, so this is going to be 1 g. G is 10 into sine 30, 10 into sine of 60, root 3 by 2. So this is going to be 5 root 3. and this one is going to be 5 root 3 for if the mass is 1 kg, and if the mass is 2 kg, it is going to be 10 root 3. Okay, and here what is it going to be? For the first one it is 1 kg, so 0.5. So 0.5 is half into 1 into 10. So the frictional force is going to be 5 newtons here. And for the second case, it is going to be 0.4. So 0.4 is 4 by 10 into 2 kg into 10. So 10 will cancel. So this is 6 newtons. So here 5 root 3 will approximately be approximately near to 9. Okay, and this will approximately be equal to 1.73 or 17.3. So in both the cases, it is going to slide. Hello, are you with me?
Yes.
Yes, sir.
Both the cases, it is going to slide. No doubt about it. Yes. Now, if you draw the free body diagram for 2 kg mass, the free body diagram here will have a force vector here like this, a friction force vector like this, and 1 kg is touching this. So 1 kg is touching this. So therefore, you will have the normal due to 1 kg acting in this direction. Okay, of course, there is a normal force here. That normal force has been taken it up by friction. No issues. And as far as the 1 kg mass is concerned, it will also have this vector mg acting, mg sin theta corresponding to that, and this will also have friction. And this normal, this is the normal for 1 to 2, and there will be a normal, the same normal. I suppose you understood the free body diagram. Hello?
Yes,
So if they are touching together, assume that initially they are touching, but now the frictions are different. So therefore, both will definitely move. Definitely move. And now if you see the acceleration, acceleration of both of them will be different. Okay, and you can see that the net force of 2 kg. What will be the net force of 2 kg? 9 minus 5. So 9 minus 5 is 4. 4 divided by, so sorry, for 1 kg mass I have calculated. For 1 kg mass, it is the net force is 4, and 4 divided by 1, the acceleration is 4 units, meters per second square. And for the second case, that is the 2 kg mass, it is 17 minus 6 is 9. 9 by 2, it is 4.5 meters per second square.
Yes.
So the 2 kg mass will accelerate more than 1 kg. Therefore, they will get separated. Hello,
Yes.
understand? So they will separate and start sliding. That's the thing. So see, you have to establish this. See, first you should know like both of them are going to slide or not. Okay, initially they are touching, but once this large sliding over this one, then you should use the mathematics to see, what are the things, and therefore now look at the options. Both the options move together? No. Both the options move separately? Yes. There is a non-zero contact force between the two blocks. Initially there is something, but they are not told initial or something, are they going to move? So you should consider after some time. And none of this. So therefore both the blocks will move separately.
Yes.
Is the right option. So B is the right option.
Yes.
Okay?
Yes.
Yes.
Right? So
Yes.
which is this problem? 18th.
19.
19th or 18th?
19.
It is the 19th? Yes, B is the option. And each and every B is the option. Right. So we'll move on to the 20th problem. You can suggest to make things better for you. Please learn very nicely, comfortably, to become highly learned students. obviously you are going to start with the free body diagram. Correct? Shall I solve? See, I am so enthusiastic to solve. So if you permit me, I'll solve. Okay. Then you try and tell me. Take some 5-10 minutes only, not more than that.
Sir, if you want, we both will solve together, sir, and we can come.
Then, but I have to keep telling now when I'm solving. Okay, anyway, take 5 minutes. I will keep 5, and after 5 minutes, I will start speaking. Read the problem carefully.
Yes.
Okay. Let me also enjoy doing this.
Done.
Okay, let me also enjoy doing this, I said. So this is the basic diagram, and then this is it. And they have told this force is given here, 30 newtons, right? And this angle is theta. They are asking you the force exerted by the plane of the block. That means now here, obviously, the normal is like this. Then the question is friction. Okay. Now they have not told the block is moving up or moving down. Did you appreciate that?
Yes, sir.
Hello.
Yes, sir.
Hello.
Yes, sir.
Yes, sir.
So they have not
Yes.
told. So one thing is,
But then
you split this 4, and obviously it is not, there is no component along this direction. So this component is there. mg sin theta is here. Okay, mg sin theta is in this direction. Now the question is, if the block is moving up, then the friction is in this direction. If the block is moving low, then the friction is in this direction. So therefore now the answer can be the force exerted by the plane on the block can be OB or OC. One of these options. If the block is moving up, then this is the friction, then the answer will be OC. But if the block is going up, then down, then this is the friction, and therefore the force is going to be coefficient. So that is something that you have to find. So it's very simple. So you calculate this mg. M is 10, G is 10, and sine theta, they have told is 3 by 5.
Yes.
Okay, so 2's are, so 6, this is 16 newtons.
Yes.
So therefore this is 16 newtons, and this force is 60 newtons in this direction, and that is 30 newtons that side. So therefore the block has to slide down.
Yes.
Yes,
So
sir.
therefore the frictional force is in this direction, and
Yes, sir.
therefore
Yes,
it
sir.
should be along the direction OB. So
Yes.
OB is the right answer.
Because
So I
Same.
hope all of you got this. For this, it's not that you don't know the theory, but it is that you have to maintain that calm and cool mind. Write the diagram and read the problem twice. So they have not told it is going up or going down. So since the situation should tell you, well, the friction vector can be this side or that side. And once you get that realization, then solving the problem is not a difficult thing. Okay, but calm and cool mind is a must here. Right? There is nothing more theory than what is given in NCERT. Nothing more, but, well, you have to do this. Well, students, shall I proceed? Hello?
Yes.
yes.
Is it the 21st problem that we are solving? Will you solve?
Yes.
We solved the 21st. Block of 3 kg is at rest on a rough inclination. The magnitude of the net force exerted by the surface of the block will be. The magnitude of the net force exerted by the surface on the block. Think opposite and do
Yes, boss.
So start with the block diagram. Magnitude of the net force exerted by the surface on the block.
Yes. Yes.
So the surface is going to give you normal, and the surface is going to exert frictional force. So these are the two forces, right? And obviously, the force by the gravity on this is mg. So this mg you will split it into two components. Okay, needless to say. So that's not important for us. So what is important is now there are two forces. Okay, N and the friction. So the net force exerted by the surface on the block is going to be root of n square plus the friction square.
Yes.
That's what you have to write. Right? So here it's going to be n square, friction is again mu m or mu into n. So it's going to be mu into n or mu square n square. So this will be m into root of 1 plus mu square. Okay. So this is the thing that they have given. The block, the kg is at rest as of infantry, the magnitude is exerted by the force. But they are not given mu, no?
The equivalent is at rest, so friction force should be equal to horizontal.
Excellent. So they have told it is at rest, friction should be equal to horizontal force. Yes, good. So this is simply going to be n into root of, okay, so here therefore the thing is this frictional force will simply be equal to root of n square plus mg sin theta square.
Mg.
Mg sin theta square. So this is n square plus mg sin theta square is nothing but m into g.
Yes.
Isn't it? So that should be 30 newtons. You don't have to do this. It should be equal to 30 newtons. So D is the So D is the force. Understood?
Yes.
So here the thing is, well, okay, we write this, mu is not known, how to do. Then you should know that mu means what? Mu s. That is, the coefficient of static friction will come into picture if it is come to the maximum value.
Yes.
Maximum value. So before that, frictional force will be equal to this because it is at rest. So the catchword is, it is at rest. Okay?
Yes, sir.
So we just solved from here. So we should want the 22nd problem. Little bit bigger.
Yes.
It's too big, man.
With bar.
Okay, give. Aditi, Anushris, I'm not at all hearing your voice. Many of them have taken Dasara holidays. The internet is restored.
What?
Internet is restored. My network is back, so I can remove the hotspot.
Done, sir.
Okay. So again here,
So, yes.
so first of all, give here, this is mg sin theta as usual, and then there is going to be the
mg cos theta.
mg will be acting down,
And
so this will be mg, so cos theta, and this, and that is n. So what should be the minimum force that should be applied? Okay. So,
sir, can I try?
yes, try.
So now we know that frictional force is given by mu s into n. So to prevent the slipping, sir, mu s n at least should be equal to mg sin theta. And we know that the normal reaction force is mg cos theta. We find out what normal reaction force is being applied, and from mu s n equal to mg sin theta, we'll find out what minimum n is required. We will compare the two, and when we subtract, we will get whatever extra force we need to apply. In this case, it will be 0, sir, because mg cos theta will be greater than n that we find from mu s n.
Excellent, correct. So you directly give the math model. So the minimum frictional force that you need here, must be equal to mg sin. Minimum frictional force that you need is mg sin theta. But with this arrangement, what is the frictional force that you are going to get here? Will be mg cos theta, okay, into mu, okay, plus some additional force must be equal to mg sin. This is precisely what you said, gentlemen?
Yes, sir. No.
Yes, tell me. Yes, where am I wrong here?
Sir, the minimum requirement will be mu into mg cos theta equal to mg sin theta.
Correct.
Am I right now?
Now you're right.
Yes, sir. Now.
That's it. So you have to calculate f from this formulation. That's all. So f from this formulation is what you have to gather here. So you should be able to do the analysis quickly here. Mu value is 0.5. So therefore this gets this side 2. So therefore this side will be m. M is 2 kg. So this is 1.5. So it becomes 4. G is 10, 40. And sine 30 is 2. So this is right side will become 20. And for this left side will be 2 into 10, 20 cos. 20 into cos theta will be root 3 by 2. Okay, plus here. So this becomes 10 root 3. So 10 root 3 is 17 point something, 17.3 and F. So F should be approximately 2.6. So C is the option. So you should do quick calculation, save those precious seconds. That is also important.
Yes.
Okay? Right. I should solve it.
You do this.
How is it okay?
Sure.
So we just completed which problem? 22. Now show me the 23rd problem.
Syllabus.
Okay. Then this is quite simple. straight away draw the wall. It's not about this. So get the wall and then draw the block, put on the wall, and then is held by applying 5 Newton of the block. So we are applying force of 5 Newton here, and here G is acting down, and if you can't coefficient between the wall is constant, the magnitude of the frictional force that is acting on it. So this is the frictional force. So this is the frictional force. So this will be approximately 1 Newton. If you take G as 10, and the frictional force should be equal to this. But they got 0.98, that means they have taken G as 90. So B is the answer.
Yes, sir.
Straight away.
Same, sir.
This is not a difficult sum. Okay, friends, shall I proceed?
Yeah. Yes, sir.
Okay, Mr.
Same.
वो ಮಾತಾಡಕ್ಕೆ ಏನು ತಗೊಳ್ಳಿ ಏನಂತ ಕೇಳಿಸಿಲ್ಲ
Good.
ಅದ್ಯಾಕೆ ಸೋಕಾಶ್ ಮಾತಾಡ್ತೀವೋ ನೀನು ನನಗೆ ಜೋರು ಮಾತಾಡ್ಬೇಕಪ್ಪ ನೀನು ನನಗೆ ಇಷ್ಟು ನಡೆ ಮಾತಾಡಿ ನಿಂದು ಟೈಮ್ ಬೇಕು ನಂದು ಟೈಮ್ ಬೇಕು
Don't matter.
So you have to go in steps to get the answer. So in these problems, first see whether both the blocks will move together. Whether both the blocks will move together. Okay, so if both the blocks move together, then that means now $100 Newton will be distributed between 10 kg and 40 kg. So condition is case one is both move together. If both move together, then what happens? The block diagram will be that for the 10 kg, the force acting will be 105, it will be 20 Newton, and since this is trying to move like this against the 40 kg, so So the frictional force on this will be in this direction, and as far as 40 kg is concerned, so the remaining 80 Newton will act like this, and that wants to, this is going like this, this is so the frictional force here, 20 Newton will act here, and so the remaining force 18 Newton will act in this direction. And what will drive it in this direction? It is the frictional force. It is the frictional force. That is the frictional force will drive it like this.
It should be 20 and 80.
Okay, now try to understand this. See here, 100 Newton will assume that it is trying to pull the 10 kg.
Yes.
So 10 kg wants to move. So now 10 kg wants to move on 40 kg.
Yes.
So therefore, it is trying to move to the left. So therefore, there can be friction between 10 kg and 40 kg. There is friction, and that should be in the right side. So as far as the 10 kg is concerned, yes, thanks again. So as far as 10 kg is concerned, the frictional force will be in this direction for the 10 kg mass. Hello?
Yes.
Yes.
Yeah. And say 100 Newton was acting on this. 100 Newton was acting on this. Okay. And as far as the 40 kg is concerned, the frictional force will be equal and opposite. So the frictional force on this will be in this direction. Okay. And this will try to, this is 40 kg. This will try to pull it like this. And if both of them are moving together, okay, both of them are moving together, that means there is no relative motion between the two. That means both must be accelerating same. So both must be accelerating same means, so therefore it means now what? This force must be getting distributed between the two. So that means this will get distributed in the ratio 10:4. That means this 100 Newton minus Fr will be the net force on this. So this net force on this should be now equal to, this should be equal to 20 Newtons. Okay, and here the remaining 80 Newtons will come on this. So 80 Newtons will come on this, and this frictional force will be that 80 Newtons. So you can see here 20 net force, this is net force on 10 kg, and this is what? This is the net force on 40 kg. So 80 by 40 is 20 meters per second to the right, and 20 by 10 is 80 by 40 is 2 meters per second square to the left, and here 20 by 10 is 2 meters per second square to the left. So both will move without any problem. Okay. Now the question is, this is if it is moving like this. Okay. Now here with the given condition, what is the maximum friction between the 10 kg and 40 kg? Okay. Now we see the maximum frictional force. So this is going to be mu, that is 10 into G into, that is first find out the static friction. Static friction they are given is how much? 0.6. 0.6. So 0.6. So this is going to be simply 16 Newtons.
Yes.
Hello? 16 Newtons. So the maximum friction can be 60 Newtons. Okay. That is, it can withstand. But this is now not just 60, it is 80 Newtons. So therefore, this block will not move with this, it has to slide. Okay, that is obvious. Now, so therefore it will slide. So if it slides, then this is for static condition. Then for the dynamic condition, so this is going to be what? 10 into 10 into, what is the friction? 0.5 into 0.5. So this is going to be 40 Newtons. Hello? So then here this friction will be 40 Newtons and this friction will be 40 Newtons. Correct? Now you see, because of this 40 Newton, what is the acceleration of this? The acceleration of this block will be 1 meter per second square in the left direction, and what is going to be the distance here? 100 Newton minus 40 will be 60. Hello?
Yes.
Yes.
So 60 by 10. So this will move with acceleration of how much? 6 meters per second. So this will move with 6 meters per second square, and this is going to move with 1 meter per second square. Okay? So the resulting acceleration of the slab. What will be the resulting acceleration of the slab? We got it as 1 meter per second square. They are given GS 9.8. We have taken GS 1. So I got it as 1. So it should be 0.98 meters. Anyway, just check it out. If you're not understood, I'll explain. Don't worry, Please ask question if you are not understood. You are all wonderful students. You are spending a lot of time. That too on a holiday. That's a holiday. And you are enjoying.
So you can explain the second part, sir. For friction, static and kinetic friction, why?
Yeah.
That is.
Okay. Arun is asking me to re-explain. Anybody wants re-explanation? Which step you are not understood? Arun
Application of friction.
Arun has asked a specific question. Anybody has any other specific question?
No.
No. Okay. Mr. Arun, the first part you understood, static condition.
Static condition.
The second condition is the kinetic. So they are going to slip. So that means the kinetic friction is going to be 40 Newton.
Kinetic.
Huh.
That is for slipping case. Yes.
Slipping is kinetic friction. So look at the free body diagram. So this I will write it as 40 Newton, and this was already 100 Newton. So 100 minus 40 will be 60. 60 divided by 10 will be 6 meters per second square. This will be the acceleration of the upper block. Right? And the same 40 Newton will act here. 40 by 40 will give you, if I take G as 1, it will give you 1 meter per second square.
Right.
So the relative acceleration between, so they are asking here the resulting acceleration of the slab. Okay, understood? Arun?
Yes, sir.
So the resulting acceleration of the okay, everybody understood here? Hello?
Sir, yes. Yes.
See, so anybody has got C. Now, is this calculation right? That the acceleration of the top block will be 6 meters per second square, and the acceleration of the bottom block will be how much? 1 meter per second square. So here, if G is equal to the resulting acceleration of the slab. So how did you get it as 9.8? Slab. So resulting acceleration of the slab is this is what they have asked with respect to ground. Now here if they are asked what is the result acceleration of the block. Now with respect to ground it is 6 meters per second square. With respect to block it would have been 5 meters per second square. Okay, so that can be achieved in this part. So get out of the problem, make a nice drawing.
Yes.
About 16?
Yes.
तो खुशी पड़ेगा ये नहीं इल्ला मारे वाले
Yes.
Hello, आराम से see what I have done. If you have issues, please ask me. Hello? Did you all get the same answer? And did you understand what I have done on the board?
Yes.
Anushri, Aditi are not at all opening your mouth. They are not even telling yes and no. Why are you doing like this? You see, you try to speak, then only you learn. Okay, shall I proceed?
Yes,
Thank you, Aditi. Whenever I ask, then only you say yes, and again you keep quiet. So we completed 25th now. You can logically split the problem and solve. So what is the assumption that you have to do here?
the ball is floor is
Floor is
smooth.
floor is smooth. Obviously, they are not floor. Then what else?
They are in contact with each other.
They are in contact, definitely.
Yes.
So okay, you are difficult to comprehend the problem, correct? So what will you do? Remove the F1 and see what happens. Remove F1 and see what happens. Okay, so if you remove F1 and see what happens, then the that is you're going to now get it like this. And if you remove F1 and say, okay, both the blocks are moving together, right? Then obviously the frictional force acting on the upper block, that is only due to F2. Only due to F2. Okay. So what will be the so this is a frictional force which is going to drive the 2 kg mass, and as far as the 4 kg mass is concerned, so this is going to be 20 Newton minus the frictional force. Clear?
So you're removing F1.
I mean, I am removing F1.
Then frictional force.
I am removing F1. Why? Only this F2 is moving, and assuming both of them are moving together. Okay. So under this circumstance, what will be this frictional force? This frictional force will be mu. Mu is half. Okay. And mg. M into g, take it as 10. So there will be 10 newtons.
Yes.
So 10 Newton force will act on this, and so if you remove this 10 Newton from this, then the force on this is also going to be, the net force on this is also going to be, the net force on this will also going to be 10 Newtons. So 10 by 4 gives you 2.5 meters per second square, and here 10 by 2, hello, will give you 5 meters per second square. Did you understand this? So there will be relative motion between the two. Hello? Hello?
Yes,
There
sir.
will be relative motion. Now in this arrangement, you know, well, you have to consider both of them will move together. Now you should not have, you have to arrest them from moving together. You have to arrest them from moving together. Okay, now if I add this F1 to this, right? If I add this F1 to this, okay, then what is the relative force between the two? F1 is how much? 2 newtons. So here it is 10 newtons in this side, 2 newtons in that side. So then now the net force becomes 8 newtons. Correct?
Yes, sir.
Now the net force becomes 8 newtons. 2 newtons, and supposing now the net force becomes 8 newtons. In this direction. 8 newtons in this direction. Then what happens? 8 newtons in this direction. Then 8 divided by 2 gives you 4 meters per second square. Right? And here also, because the same frictional force acts on both, so if I take this also 8, then this becomes what? 16. So 16. Sorry.
Frictional force is 10 on this.
Huh?
Frictional force is 10 on this. 8 Newton is the net force on the first part.
The net force on this is 8 Newton. So 8 by 2 is 4 meters per second square will be the acceleration of the top one. And here what happens?
Frictional force is 10 newtons.
Friction force is still 10. So 20 minus 10,
Is 10.
10,
Right.
and 10 by 4 is 2.5 meters per second square. So there is going to be relative motion between the two. There is going to be relative motion between the two, right? Only thing is, well, so they are asking you what? The force of friction acting between the two blocks. See, if you say the force of friction is 10 Newton here and 2 Newton is acting in this direction. Okay, so therefore now the net force on this side is 8. If the net force on this side is 8,
Easier. Yes.
then what happens?
So this block is going here. Acceleration of the top block is more than the second block. So that 4 meters per second square into 1.5. Then is correct.
What is correct?
Frictional force should remain continuous.
Friction force will
Remain as 10.
remain same. See now here, what we have calculated is the maximum frictional force. This F is here. F is the maximum frictional force we have calculated.
Yes.
So this one we have calculated is F max. F max is what we have calculated. Okay. Now, if you add F2, then the required frictional force. See here. See then this is the maximum frictional force. So if you add 2 to this, if you add 2 to this side, see the frictional force is self-adjusting force. Self-adjusting. It can become less also. Now, assuming that the frictional force has become, is now self-adjusting. See, formerly it need not be, because you see now, formerly it need not be. See, we have calculated what here 10 as maximum frictional force. Understand? So, otherwise you look at this like this. You look at it like this. This 20 Newton. If you assume both of them are moving together and F1 is not active, or let's do it the other way. Let's do it the other way. Okay, I'll just keep this. I will not close this. Okay, we started off like this, and we are ending up with some confusion. So let's start like this. Now assume that both of them are moving together. Then what is the net force acting on the system? The net force acting on the system will be 20 minus 2 will be 18.
Yes.
Okay, it will be 18. So 18 divided by 6 will give 3 meters per second square is the net acceleration.
Yes.
Hello, are you with me?
Yes.
Right? 3 meters. So therefore now, if 3 meters per second square is the acceleration for the 4 kg mass, 4 kg mass. So if this is accelerating at 3 meters per second square, 3 force are 12. Okay, so this should become 12 newtons. I mean 12 newtons will be retained here. Then remaining 8 newtons. Okay, 12. The net force on this 4 kg. This will be the net force on the 4 kg.
Yes, sir.
Are you getting it? See, I am considering now the net force on the system. Assuming both the masses are going together, the net force is going to be 20 minus 2 is 18. Hello, are you there with me, others?
Yes.
Hello?
Yes, sir. Yes.
So the net force will be 18. So 18 divided by 6, 3 meters. So that means both the blocks are moving with 3 meters per second. So in that case, the force acting on 4 kg will be 4 into 3 will be 12 newtons.
Yes.
So the remaining, so 12 newtons is what? The net force. 12 newtons is the net force on this.
Yes,
Now, here you see 12 newtons is the net force acting on this, and therefore 8 newtons must be the friction. Because now on the 2 kg on the 2 kg, the frictional force, if it is 8 and this is already 2, okay, so totally it is going to be 8 minus 2 is 6. And the acceleration, and 6 is the net force, and 6 divided by 2 gives you 3 meters per second. So therefore the top block will also move with 3 meters per second. Okay, now let me explain it once again. Hello, everybody there?
Yes.
So if you take this whole thing as a system, okay, then if you take this whole thing as a system, the net force acting is 18. And the total mass of the system is 6.
Yes.
So the whole system is going with 3 meters per second square. Is that understood?
That is understood.
Yes, sir.
Now that means now 4 kg is moving with 3 meters, 2 kg is moving with 3 meters.
Yes.
Okay, so the net force on 4 kg, the net force on 4 kg has to be 12. Okay, then net force on 4 kg has to be 12. So 12 divided by 4 will give you 3 meters per second square. So lower block will move with 3 meters per second. Hello?
Yes, sir.
Yes, sir.
Then but the total force acting here is 20. So, but this needs only 12 newtons to move it with 3 meters per second square. Remaining 8 newton has to be the friction between this block and this block.
Yes.
And that 8 Newton, if you put it here, okay, 8 Newton if you put it here, then 8 Newton minus 2 Newton will be 6. 6 divided by 2 will again give you 3 meters per second square. See, here the thing is, the frictional force is self-adjusting force. Right? Understood?
Yes. Yes.
So, supposing you keep on increasing this force, then the demand for the frictional force will keep on increasing. So, here you see it is 8 Newton, it will become 9 Newton, it will come close to 10 Newton, and both the blocks will move together. Hello?
Yes, sir. Yes.
But if you go beyond that particular point, then the demand for friction will be more than 10 Newtons, and then they will start slipping.
Yes, sir. Yes.
Is it clearly understood?
Yes, sir. Understood.
Everybody there?
So the friction on the 4 kg blocks,
On
the 4 kg blocks,
Huh.
that should also be 8 only.
No, 8 only.
Then 12 minus 6.
See, that's what I said. You are not listening properly. That's the problem. I told 12 Newton is what? Net force.
Okay.
And it's already accounted for.
Okay.
So 20 minus 8.
Okay.
Yes, sir. Yes.
Shall I proceed?
This will be the case.
Yes, sir.
No other case.
What other case? And they are doing 8 Newton. So A is the option.
Okay.
Yes.
What else can we do? Nothing else. So this is how you have to tackle. So first we do it like this. Okay, something got wrong. Then do like this. Okay, try to get hold of the problem. So this is how the examination situation is. Very important is now you see I am solving these things in front of you. Right? So I am also as if I am writing an exam. For me, really it's an examination. For you, it is not an examination because if you do a mistake, it is okay. But if I do a mistake, well, the whole world will come to know. So I will be under pressure. Okay. So therefore, there's an examination for me when I am solving it in front of all of you ex tempo. The same situation. So, but yes, nonetheless, you see, I am maintaining a cool composure and I am handling it. You also have to develop this. That's what the message that I want to give. All right.
Yes, sir.
Thanks for telling yes. So this is the last problem, solving 530. Find the angle of incline in the block of mass M just start slipping. The distance covered by the block is thrown up the incline with the speed of V0. Okay. Block just starts slipping. You know what it means. This angle is phi. Okay, it means under this circumstance, mg sin phi is equal to the frictional force. Is equal to the frictional force, and that's equal to mu mg cos phi. This is the condition that they have to. This we will throw up the V0. So if you keep it here and give it a velocity of V0, okay, then the distance covered by the block up the incline, the distance covered by the block if thrown up the incline with initial speed V0. So they're asking you the distance covered. That means you could have moved from here to say here. So this distance d is what they're asking. You can solve by many methods. So when the block is moving up,
Friction is worse.
so friction will be ulta.
Yes.
So the initial velocity vector is like this, but then there are two forces. One is the retardation mg sin phi and the retardation due to friction. Right? This will also be there.
Yes.
So these are the two forces that are acting, and therefore the acceleration is going to be what? Acceleration in this direction.
2 mg.
Okay, acceleration in this direction will be
2 g
g sin phi.
plus
See, g sin phi
plus mu g cos
plus mu g
cos.
cos phi.
Yes.
This will be the
Roll
acceleration.
up the incline. Should we consider as projectile that we had done block on inclined plane?
So, hello. Why do you want to always think like that, man?
They said thrown up still. That is why
See,
they are not said push.
Phi is the angle of the incline of the block, just a step down, the distance covered by the block. If thrown up the incline means you have pushed it like this. Correct, no? You have put everybody to confusion.
Then sounds with throwing the block.
No, it is thrown up the incline. If they are not told simply thrown up. Then if they say throw up means, they should give you the angle which they have thrown. Theta also they should give, no?
Yes.
Oh.
So, yes.
So here the distance moved is V0 square is equal to 2AS, isn't it? So this is 2A into the distance that it has moved must be equal to V0 square.
Yes.
Correct?
Right.
Yes.
But then we get here V0 square by 2G into bracket sin phi plus G plus
mu cos.
mu cos.
We know that mu tan
phi.
phi.
Mu is tan phi.
So we get 2.
Yes.
So mu is tan phi. Correct? Mu is tan phi. So I get here that will be equal to sin phi or 2 sin phi. So I get here V0 square by 2G into 2 sin phi.
Yes.
Okay, so we get here V0 square by 4G into
Sin phi.
480. Right. Do we have an option?
Option.
Yes.
V0 square by 4G. Yes, V0 option. Okay, friends.
Yes, sir.
Done.
Yes, sir.
So the time is now
5:30.
5:30. So I will stop the class. Okay.